All right, we're going to get into our trigonometry unit. It's kind of a short one, and there's a lot of different things going on. Okay, so make sure you're taking notes and you're really listening to what's going on in each example. Okay, well, first, we kind of need to know, well, what is trigonometry? We kind of understand what geometry and algebra entail, but trigonometry is the study of the relationships between the sides and the angles of triangles. Okay, and we already have, the Pythagorean theorem, and we also have special right triangles to help us find those missing side lengths. Okay, but now we're adding in the trigonometry portion, and you'll be seeing sine, cosine, and tangent quite a bit. Okay, so we can always go back to the Pythagorean theorem if we can, and we can always do the special right triangles if we can. But there are going to be those cases where we can't use the Pythagorean theorem and we can't use special right triangles. So trigonometry is kind of like that third step we take in solving for side lengths or even angles in triangles. All right, this is an important slide to have written down. This is kind of like the base of trigonometry. Obviously, we have three sides in every triangle, okay? And if you take a look at these pictures, notice they both have hypotenuse on it, which we already know the hypotenuse is the side length across from the 90-degree symbol. Okay, now we have these two other side lengths that kind of change depending on what angle we're talking about. Okay, and notice in this first example, we have angle A right here, and the adjacent side to angle A is the one that's right next to it. So it's the leg. Adjacent kind of means next to. Okay, so if we're talking angle A here, the adjacent leg would be this guy right here. Now the opposite side, okay, seems kind of obvious, right? The one that's opposite the angle, okay? And that's what we're talking here, okay? The one opposite, okay? And that's if we're talking about angle A. Now let's say we're talking about the angle that's up here, okay? If we're talking, now that's just a Greek symbol for theta, okay? It's this, you might see it a few times. It's not really anything, just kind of like an x value, okay, an unknown. Okay, so if we're talking about this angle up here, the adjacent leg is now this one, the one next to it, right? And the opposite is now the one at the bottom. Okay, whereas in the other triangle, this first one, notice that we had the adjacent one towards the bottom and the opposite one towards the right side. It all depends on what angle is being identified. Okay, so they'll give you an angle, and it's your job to decide, okay, where is the opposite from that angle? Okay, and then which leg is the one next to it? Okay, now I notice that you might think like adjacent. Well, there are two sides that are adjacent to angle A. Okay, but one is always going to be the hypotenuse. Okay, so that's always the first one you kind of want to identify in a triangle is the hypotenuse. I think that's always the easiest. And then recognizing, oh, this one is opposite. And then the one that's left last is the adjacent. So always try and find the hypotenuse first, the opposite, and then the adjacent. I always like to label them with like an H and then an O and an A, so I keep it straight for myself, and I'll kind of show you that in the examples. All right, so sine, cosine, and tangent are three words that maybe you've seen. You've probably even seen them on your calculator. Okay, well, sine, okay, it's abbreviated S-I-N. Now we never call it sin. It's sine, okay, sine, okay, like a stop sign. Okay, it's the ratio of the opposite leg and the hypotenuse. Okay, so I would write that down. Okay, sine is always associated with the opposite leg and the hypotenuse. That's kind of important, okay, because the other two, cosine and tangent, are related to other two legs in the triangle. Cosine is the ratio of the length between the adjacent and the hypotenuse. Okay, so cosine, adjacent, hypotenuse. Okay, and remember sine was the opposite and the hypotenuse. And then tangent is the opposite leg and the adjacent leg. Okay, that's the ratio between those two sides. Okay, so make sure you write down those couple things because I think that will be important coming forward. Okay, or if you feel like this might be better for you, I know it's kind of laid out a little nicer. Okay, when we have trig ratios, remember we talked about how sine was the opposite and the hypotenuse. Cosine, we talked, was the adjacent side and the hypotenuse. And then we just said that the tangent was the opposite and the adjacent. Okay, so actually, this would be probably the most important thing to have written down. Okay, because we're going to be using this in all of our examples. Okay, now you maybe see this random couple words here. Okay, and that's just to kind of help you in your head remember the ratios. Okay, so we call it Sohcahtoa, and you'll hear me, I'll write it on my paper a lot, I'll have it written on the board a lot. Sohcahtoa, okay, helps us remember these ratios, that sine, S, is the opposite and the hypotenuse. Okay, and then we have cosine is the adjacent and the hypotenuse. And we have tangent, which is opposite and adjacent. Okay, so Sohcahtoa is just kind of a way for us to remember all of this here. Okay, and it's important that this order stays the same. So opposite side is always up top when we're talking sine, hypotenuse is always at the bottom. Okay, I understand it's a lot. Okay, I think it'll make more sense when we do an example together. Okay, so we're going to get started in it, and this is going to be kind of what most of your examples will look like. You'll be given an angle measure. In this case, we have 67 degrees. You'll be given a side length. In this case, we have 14, and you'll be given an unknown. Okay, so what we're going to do first is I always like to identify my side lengths. So if we say, let's say this is a right angle, okay, they always have to be right triangles to use Sohcahtoa. Always right. Okay, because otherwise we don't have a hypotenuse. So here we have our hypotenuse. Okay, the opposite is our x, so I labeled it O. And then the adjacent is what's left, the 14. Now, if you notice here, we are given the adjacent, and we want to find the opposite. Okay, so if I go back to my Sohcahtoa, see, this is where it comes into play, I can identify which one has the O, opposite, and the A, adjacent. And I notice that my tangent has opposite and adjacent. Notice that sine only has opposite and cosine only has the adjacent. Okay, so I'm going to use tangent. And if you look back at our ratios, okay, we had tangent, parentheses, angle, equals opposite over adjacent. Okay, and that's exactly how we're going to set it up. Okay, the angle measure always goes in for the parentheses by our trig. So in this case, we have 67, because that's our angle measure. Our opposite side is x, because that's what we want to find. Okay, and then the adjacent side was 14. Okay, so this is what we're going to be solving here. From this point, that's not our answer. Okay, we're going to be finding out what x is. We're going to use a little algebra skills. Okay, if I need to solve for x, I need to get rid of this 14. So I'm going to multiply both sides by 14 to get my x by itself. So now I have equals x, right, because my 14's canceled. So I have 14 times tangent of 67. And now we could say this is our final answer, okay, but now we're going to get to going into our calculators, okay, and you need a graphing calculator for trigonometry, okay. It's not going to work the best if you do not have a graphing calculator. Okay, so you should have all this written down on your paper. I'm going to bring up my graphing calculator. Okay, first thing you need to do on your graphing calculator, you need to go to the mode button, and you need to make sure that you are in degree mode. See where I have that highlighted there? You need to press enter to make sure you are in degree mode. Otherwise, you will not get the right answer. Now, once you're in degree mode, if you don't go in and switch it, it'll stay there. Okay, so we can quit out then. And notice that we have our sine, cosine, and tangent buttons right there in the middle of our calculator. Now, if you remember, our answer was 14 times tangent of 67. So that's exactly what I'm going to type into my calculator. I'm going to do 14 tangent 67. I'm going to press enter. So that's telling me that my side length is about 32.98 units. Now, it's not perfect, like the Pythagorean theorem or special right triangles, okay, but 32.98 is about as exact as we can get. So our final answer for x, 32.98 units. That's our final answer. That's our side length. All right, let's do another one. All right, this case here, I'm given the hypotenuse, and I need to find the opposite. Okay, so if I go and look at my Sohcahtoa, I notice that we have opposite hypotenuse, that's going to be sine. So my sine ratio, sine equals opposite over hypotenuse. Angle measure always goes in for x. So I have sine 35 equals my opposite over my hypotenuse. Now again, we need to solve for x, so I have to multiply by 7 on both sides, just like we did in the last example. So now I have 7 times sine of 35 equals x. And that's what I'm going to plug into my calculator. So I'm going to go to my graphing calculator, 7 times sine of 35, and press enter. I should get about 4.02. Okay, so about 4.02 is our final answer. So x equals 4.02.